this morning. I hope everyone's having a good morning so far, and I hope the next 45 minutes are going to be really, really useful. As a quick introduction to who I am, I'm Adam Luca. I'm the Chief Technologist for Security here at Softcat, and I was involved in our response with our customers around the ransomware attack, specifically WannaCry and NotPetya early in the year. And for me, this is really where some of this, the ideas for this webinar and what we're going to show you today came from. I'm very proud to be joined by Johan from Splunk. Johan, do you want to say a quick hello to everyone?
Yeah, hello guys. Hi, my name is Johan Bjerke. I am a security engineer working for Splunk. I've been with the company for a bit over 4 years now, and I am the subject matter expert for security in the UK. And I'm going to showcase how you can use Splunk to detect ransomware and general malicious activities at scale.
Perfect. Thank you, Johan, and yeah, thank you very much for joining us and guiding us through the technical elements of some of this demo. So I probably think it's best to just go over a quick agenda about what we're going to talk about today. So a few different bits. We're going to talk about, I guess, the beginning. All good stories start with the beginning, and I want to talk about really where the idea for this webinar and this approach came from, and sort of how that developed from our response to WannaCry and to NotPetya and to some of these large-scale ransomware attacks we saw over the last sort of year. I'd like to talk about what's changed, so I guess give you an understanding of where the traditional tools fit into your product stack, and actually where sort of a more data and analytical approach fits into that, and the differences between those. Finally, explain a little bit about why they need to be supplemented, and why that traditional approach isn't enough. Talk to you a little bit about how we can start to take a data-driven approach to identifying ransomware, both the characteristics of the ransomware, known IOCs, but also enable automated responses. And what we've done is we've broken this up, because I've unfortunately, probably like all of you on the call, sat through many hundreds of WebExes, and we want to make this fairly interesting. So what we're going to do is we're going to set up a little scenario, discuss why that scenario would be useful, and then Johan is going to take the reins and show you how we can use the Splunk platform to actually fix that problem. So I'm hoping that what that will end up with is a WebEx and a webinar that is useful, and you can understand directly how you can use the product rather than sort of taking you through a 45-minute dashboard tool, which is not always the most interesting thing on a Wednesday morning. So perfect. I hope that sounds good to everyone. So let's just talk about where it started. So I'm not going to sit here like a lot of people and tell you that ransomware is a thing, because I think the fact you're on this webinar, ransomware is a thing in the same way cybersecurity is a thing. So what I'm going to talk a little bit about is actually some of the real-world experience we had dealing with customers during the WannaCry incident. WannaCry sort of took place, I guess, Friday afternoon. I was still at work, looking forward to going home at 5 o'clock, actually, and we started getting reports from around the world that this big ransomware attack had started taking place, and it looked pretty large. It looked kind of larger than your normal drive-by campaign that was taking place. And we started getting reports from our own customers actually coming to us and saying, hey, we're concerned, we're worried, what should we do, what advice should we take? So we sort of went into a bit of an instant response mode and started drawing up communications and aggregation of information for those customers to consume and to use. And at that time, I was working very closely with our public sector business, so a lot of the NHS organisations, and unfortunately some of them the ones that were actually impacted. And I think we proceeded to spend the weekend shipping pizzas across the UK. But actually, what does that got to do with anything? And actually, when we were kind of sitting and talking to these customers and discussing, actually, here's the known IOCs, and here's the known file hashes, and potentially here's the known CNC servers, what became immediately apparent to me was actually, out of all the customers I spoke to, and it probably must have been nearly a couple of hundred over the weekend, most of them weren't impacted. Most of them didn't get hit by WannaCry, but yet most of them were still spending their weekends working. And I don't know whether you guys are all sitting there and thinking, maybe that relates to me and I can understand what that feels like. But actually, there were so many of us that were so desperate for data, and we had the people above us saying, what's our response to this? Have we been breached? What's our risk level? Do we need to go into action stations on Monday? And actually, people couldn't answer that basic question. And that was kind of quite frustrating for most of my customers, and quite frustrating for me. Here I am with all this information. I've got the file hashes, the file locations, and I can give you all of that. That human intelligence had moved very quickly. But we had no way of going across the network and simply looking at all of the different assets that you had and saying, is this present in any of those assets? And I thought that's got to be crazy. There's got to be a better way of doing that. And I think some of this has kind of been rolled into EDR technologies, so endpoint detection and response, or, you know, if you have a incident detection and response platform or maybe a managed SOC, and, you know, and that's sort of great if you have that functionality. But for most of my customers and most people I spoke to, they didn't really have that facility. So I kind of set about working out a way and speaking to Splunk and working out, you know, how can we leverage normal enterprise technologies to enable customers to get the right information. I was going to say I had customers literally driving engineers across counties to visit remote sites because actually there was nobody there at the weekend. So they needed to ascertain whether or not they'd had an incident or had a breach. But actually, you know, they wasted hours and hours and hours verifying the information. So that's kind of really the reason why we put this together. I want to show you how you can use Splunk today to, at scale, detect whether or not you've got a ransomware issue or a malware issue, I guess more broadly than that. If you do understand the impact scope of that and understand what it hits, and then finally understand what action you need to take. You know, more information about the situation is always going to lead you to be in a better environment. So that's where we started. So what sort of changed with ransomware? You know, ransomware's been around for a long time. It's not particularly interesting anymore, but I think the interesting piece is that we started to see ransomware move into the sort of territory of worms. I mean, it's kind of crazy to think that we've been so long without a good worm. You know, you think about Conficker or MS Blaster or you know, a number of the previous worm attacks that have existed through the years. And actually, you know, it's kind of crazy we've not had a good one for a while, for want of a better term. And this is definitely what we saw with that Eternal Blue exploit coming out. You know, a self-replicating remote code execution when you combine it with the double pulsar exploit as well. And actually, we can immediately take a single entry point and very rapidly propagate that through the network. And that's a pretty unique proposition. And then interestingly, I think when we look at Bad Rabbit that happened only maybe last week or the week before, it's interesting how that technique has not gone away. You know, I don't know how often we're going to see exploits that are quite as powerful as Eternal Blue, you know, that SMB remote code execution, but actually we don't need them. I think what Bad Rabbit showed us was, you know, we don't actually need an exploit to use this stuff. Actually, an SMB share with a lateral movement, you know, bringing along credentials that have been harvested, or leveraging something like Mimikatz to exfiltrate the sort of the authentication databases that exist locally, attempting to crack those, you know, is a very, very easy way to laterally spread your attack without needing any sort of exploit or zero-day. You know, and this is stuff that exists within every single one of our organizations. You know, take Softcat even, like we have client networks, as I'm sure you all do. You know, on a wired network, it's almost impossible to provide total isolation. You're always going to put clients next to each other. You know, they're always going to sit into some sort of VLAN. And I got myself in trouble recently with our technical architects because I sort of very quickly as a security guy went, oh, well, private VLANs exist, so everything must be sorted, you know. And for those who aren't familiar with private VLANs, they're essentially a VLAN that isolates each of the client within the VLAN, so you now can't communicate laterally within a VLAN. And they're kind of quite a good idea, but then you suddenly realize they break a very, very important thing that we use every day, namely VoIP. So if any of you are sitting there going, private VLANs are the future, they're probably going to be very difficult to implement if you run any sort of VoIP networks. So that's sort of what's really changed. And actually what that identified very quickly is that you need to be much quicker at identifying where the attack has come in, if it has, and actually if it has come in, understanding where the attack has spread to. Because what we're now seeing is a migration from the requirement of the entry point of that attack, like the WannaCry stuff, which was delivered in via SMB, but to now actually be utilizing a dropper, so actually coming in via a web download or some sort of other file, whether that's an email attachment, a macro, and actually coming in via that dropper and then using that lateral movement to move within the network. And I think that, for me personally, and I'd probably hang my personal reputation on that, that is the future. You know, why wouldn't you do that if you're an attacker? You know, you're going to increase the number of machines you infect. You know, you're going to make it a lot more difficult to recover because actually you might hit stuff that people haven't got a good backup on, you know, making you more likely to pay the ransomware. And ultimately, that's what it's all about. So actually, let's talk a little about some of the traditional tools. So to finish this actually. So actually, people who weren't massively impacted, as I mentioned, were able to assess their posture. So assess immediately, you know, how vulnerable am I? How many patches do I have missing in the case of a vulnerability-based spread? You know, investigate the impact. So actually, do I see any evidence of that on my network? You know, and that becomes more and more difficult as you get larger. And then finally, decide and respond. Actually, one of the greatest tools that this platform will give you, and ultimately what we're trying to do here, is give you information to make the right decision. do you need to break that glass cabinet on the wall and grab the emergency plan out and deploy the emergency responders, so to speak? Do you need to activate your DR plan? You can only make those calls if you have the right information, and I honestly believe that most of our customers currently don't have the ability to have that information, and hopefully by the end of this you'll have an idea of how you might. So let's talk about what traditional tools can do. So ultimately, I think a lot of people, when they think about ransomware, and actually there was an interesting BBC article, I think, last week in which I think it was the Department of Health or at least somebody in the government sort of gave the NHS a fairly good kicking and said, if they deployed the patches, it would have been simple. And I kind of think actually that's a bit unfair. That sort of hygiene is very, very difficult. And actually, patching and keeping your signatures up to date, yes, is a very important part of your security model and your security control system, don't get me wrong. But at the same time, I don't think anyone would argue that it's totally impossible to get a 100% success rate. Because actually, what about things like mutations? What about malware that is now encoded on the fly? What about polymorphic malware, malware that actually changes itself as it downloads, and potentially, your dropper, so the thing that's bringing that malware into your environment, is making a unique malware sample just for you. Unless you move to potentially a signatureless system, in which potentially you have now more capabilities to defend against that type of ransomware by using machine learning or heuristics algorithms. But even so, it is a numbers game. And actually, if you can defend against 1 million ransomware attacks and you only let one through, it doesn't matter. So I think we still need to think beyond that element. What about endpoint protection solutions? So actually, I talked about the effectiveness of signature and non-signature based detection systems, but, have you got any way of verifying it's true? Can you prove a negative? And that's kind of really where this all boils down to is, do you have the tools to prove a negative? You can prove do you have malware, because if you have malware, your antivirus went off and goes, bing, you've got malware, and, you get a lovely report. But it's when you don't know, and it's that ambiguity that's incredibly difficult. Finally, people sort of say that ransomware is an availability problem, which I quite like. If you've got a confidentiality, integrity, and availability are the 3 pillars of security, well, ransomware is a loss of availability. And I think academically, I wouldn't disagree with them. A good backup is a great strategy, but it should be the last strategy. Your backup is there as your last line of defense. You don't want that to have to become a massively operational task by continuously having to restore that system. Also, are you able to verify that the backup is actually working and you've got a backup of that location? I think there's countless of stories of people who rely on their backup solutions only to find out that, the backup wasn't actually working in that particular area of the network. So that's kind of the traditional tools. And to sort of answer this, Splunk came up with this idea of Splunk Insights for ransomware. So I am a bit of a non-believer, shall we say. I don't drink too much of the Splunk Kool-Aid, although I'm sure they probably throw things at me for me saying that. But, I think a lot of people, when they look at Splunk, Splunk is quite often in the marketplace considered quite a difficult product. It's enterprise level, it can do almost anything. I'm sure if you put some effort into it, it would make you cups of tea, or at least give you analytics on it. But people see it that you've got to put a lot of effort in to get a lot out. And I think what Splunk has done is part of their insights package is they've realized that. They've realized that customers, want to buy a product that's much more turnkey. And what the insights platform is designed to do is it's designed to build and fix a particular use case or a particular problem in your environment. So it comes much more pre-set up. It comes up with pre-built dashboards, a lot of pre-built templates, and you'll see a lot of those. All the stuff Johan's going to show us today is literally out of the box. So no, there's no smoke and mirrors, there's no pre-set up. This is literally what you can consume today. And that ultimately means that when you put this platform in, you're getting immediate value out of it. And I think that's totally different to the traditional way that Splunk has worked, and I think is a much more useful way of doing it. So I think the question now we need to ask ourselves is, actually, why would you bother buying it? At the end of the day, you're all sitting here on a webinar, and I'm sure some of you are sitting here out of interest, but, some of you are potentially sitting here thinking, maybe this is something I wanted to look at. Maybe I might go ahead with this. And I think the question you always have to ask yourself then is, why am I spending money? And I think it really comes down to a very simple question. At the moment, how many IT staff would it take you to assess the posture of your environment, to investigate a ransomware breach and to make good and fast decisions? Those 3 pillars take a lot of time with current tools, and I think actually in environments where you say, well, I don't spend any time doing that, it's not because it doesn't take any time, it's just because you avoid doing it altogether. And I see that very commonly at the end of the day. Actually, when we don't have enough time to do all the right things, we try and prioritize, and actually sometimes we avoid doing hard things because, that's highly time consuming. You could get sucked in on one task for, several weeks potentially. And we ignore those things, and then eventually they kind of come around to bite us and cause us issues down the line. And that sort of is what happened very much with the WannaCry incident. It wasn't so much that somehow it was a magical attack and it was a 0-day. It was an exploit, totally correctly, it had been out for a couple of months. But actually what had happened is we'd got so caught up in our other tasks, the patching and that hygiene stuff took so long that we'd kind of forgotten about it. And actually it came back to sort of bite us, really. So I want to make sure that customers understand that, by investing in this stuff, you are getting time back, but you're potentially getting time back on tasks that you'd otherwise ignore. So what does it mean to assess posture? So if we think about, how many people it might take or what the task might be, if you want to get endpoint visibility of your environment, have your backups been run recently? What's your system patching level looking like? Have you got any old operating systems? And if you do, are they isolated? Has your internet traffic changed? Are you suddenly seeing spikes in traffic levels from a particular workstation? Are they potentially talking to each other? Are you pulling net flow information in and you can suddenly see, oh, that's really weird. This workstation 1 and workstation 2 are now talking to each other over SMB, pushing lots and lots of information. That's really unusual. Have you got any unclean infections? So, are you not monitoring your antivirus platform constantly? Actually, have you got any machines that have been flagged for inspection but actually haven't been totally cleaned? Do you know where any of the bad files are? One of the really interesting things about WannaCry and actually a lot of the recent sort of major ransomware attacks is that the human intelligence was quicker in most cases than the antivirus products. I was actually, with the Bad Rabbit attack, I was sitting on my laptop in the evening and got an alert through from one of our third-party security feeds that this stuff was starting, and it already had the hashes on it. I put those hashes into VirusTotal, and to save embarrassment for the vendors, VirusTotal has 54, I think it's 54 or 64 different antivirus products on it, and this was the hashes 20 minutes after the outbreak had taken place. Only 16 of them had caught it. I ran them again in 3 hours. It was up to 50%. So it just shows you that often we can have intelligence at a human level, from the internet, from various sources, that actually is far quicker than actually some of the threat feeds that we're getting in, and some of the signature feeds, especially from our antivirus products. So, can we find those bad files? And actually, is there any signs of spear phishing? Are we seeing any interesting email flows towards particular individuals in the organization? So how can I take all of that information and get that posture, get that overall threat view for my organization? And actually currently, how hard would that to be? And actually, by implementing Splunk, let's see how quickly we can do that. The next pillar, central analysis. So actually, I think I've got an issue. So the first one is understanding, how well would I defend against an issue? The second one is, I think I've got a problem, but I need to validate it. So, what executables or hashes are running on vulnerable systems? What networks are they on? Who's got access to those? How did a file get in? A really, really useful one, and actually particularly important, and I'm almost grimacing in saying it, but as part of GDPR, everyone has banged on about 72-hour breach notification. The bit they don't bang on a lot about is that if you can identify that it isn't likely to impact the rights and freedoms of the individual, you do not have to disclose. Please seek a lawyer for further legal advice. But from my perspective, my interpretation of that ruling is you don't have to disclose. It has to impact the rights and freedoms of an individual. Your room booking system, if that gets compromised, and your meeting room booking system, is the data breach and contained within that likely to impact the rights and freedoms of individuals? Probably not. We probably find that Dave has been having the meeting room for too long, but other than that, it's not going to impact anyone. So by being able to identify how something got in and what it attempted to do and how it spread, you can very quickly lock down your incident area from something that might go from this is my whole network and I've got to scope in this whole area with all these hundreds of servers down to, well, I know it was that exact box and I know it didn't move from that box because actually I've got the logs to prove it. So I'm going to take that box offline, I'm going to scrub it, I'm going to clean it, I'm going to put an incident response together, and then I'm going to make a decision about whether I'm going to disclose that. You can't make that decision unless you have the information to back it up. And then finally, you talk about the idea of machine-to-machine communication, this idea of working at the speed of a machine. And actually that's one of the sort of the greatest things about human beings is we're able to do things and be creative and infer things from incidents. And, we're really useful in an incident management perspective. What we're not very good at is being very, very quick. You know, one of the great things about computers is they can react in nanoseconds. You know, they can take any sort of input and immediately create a response. And that's particularly important with the idea of any sort of wormified or self-replicating malware. You know, that malware is going to replicate at the speed of a machine. Your response is not going to. And that's something to be very, very clear about. You know, when you're expecting that somehow you're going to see all this bad stuff happen on the network and you're going to make a human response to it, you know, by the time you make that human response, it's going to be over. It's already going to be done. The damage is already done by that point. Even if, you know, you're the fastest left clicker in the world and you're going to press that button that shuts the whole network down, I would still say the impact zone is going to be pretty large. So actually, how can you start to take that data and use that to create analytics-driven decisions? So how can you take data where you've correlated different events and you've taken an action because you have a level of certainty? And actually, can that action be disabling network access, you know, revoking someone's credentials, you know, actually whatever you can start to think about, you can start to create security orchestration platforms, and they're kind of known as playbooks. So you want to have a set of playbooks. So we might have a ransomware playbook. We detect ransomware activity on someone's user account, you know, particular types of behavioral analytics, and I want to remove their SMB credential access, because actually I don't want them speaking to anyone. And I'm then going to open them a support ticket within a service desk platform that then already has the information in when they call up and go, well, I can't save anything anymore. So it's by creating that automated response we can start to get ahead of the ransomware attacks. So let's talk a little bit more about the actual platform. So interestingly, the ransomware platform is going to provide you that single source of truth, and it gives you that ability to act as an investigator. And when you're kind of acting as an investigator, there's a number of different questions you're always asking yourself. You know, what's happened? Who was involved? When did it start? When was it seen? How did it get in? And how do I contain it? You know, those are the questions I think. If you ever go into an incident response scenario, or if you ever done any DR planning, you know, that's the kind of thing they teach you to do in war rooms. You know, that investigative mindset and that evidence gathering is massively important to making the right decision. And the great thing about Splunk is, you know, if you're a more technical person, this is sort of how you can dive into some of the deeper stuff. So actually, you know, is there a connection from an alert? So we're correlating multiple different things between an IP address, host, malware, and other activities. So, you know, do I see on my firewall that endpoint is speaking to a known CNC server and correlate that against potentially an increased level of SMB traffic on that machine? You know, is that a good level of correlation to then start some sort of logic? So actually go and search the network logs and determine the initial entry point. Go and look for how that file came in, or potentially that piece of malware when you connect to a site. And that's going to return you some findings. So actually that might not have even come in via the network. You might be immediately thinking, oh, it's going to be an email attachment or it's going to be web. Well, it could have been a good old USB. You know, I kind of think that's kind of got a bit out of fashion now. I remember everyone used to be massively scared of plugging USB devices in, and almost nobody plugs anything in now. And it's all sort of spear phishing and drive-by download types. But by having that information, you're going to know immediately, you know, how to take the right action. And ultimately, that's going to require you to take lots of data in. You can't look at that in isolation. And, you know, for anyone who's done any sort of root cause analysis or troubleshooting, you know, an assumption makes an ass of you and me, and that's always the truth. You know, you think you've locked the source of something down, and you've looked at the network logs, you've looked at the application logs on a box, and you think you've got it. And it turns out it was a red herring. It turns out it was nothing to do with that scenario. So by having this aggregate view, you know, you're going to have a much greater chance of getting straight to the cause and making the right decision early. So that's sort of the end of from me talking at you. I guess, Johan, are you still here? Have you fallen asleep?
No, I'm still here.
Excellent. So Johan, I guess in the next session, what we're going to do is try and show the guys how they can use some of the different scenarios and actually how they start to work in the Splunk platform. So I guess I'll do a little introduction, and I'll pass the presenter over to yourself, and you can show the guys the platform. Is that happy?
Absolutely, that's fine.
Perfect. So the first scenario we came up with was a known IoT malware scenario. So that's kind of a really posh way of saying, you know what you're looking for. And this is very much the WannaCry scenario. WannaCry, not petty, a bad rabbit. Everyone had the hashes. You know, the SHA-256s, you know, everyone had those. They were all out there on the internet. If you Googled within about 10 minutes of the actual breakout, you could see people on Twitter telling you that information. And you're kind of sitting there going, how the hell do I use that really useful piece of information and go and work out whether that applies to me? So, Johan, do you want to show us a little bit about how we can do that? So I'm just going to flip the presenter over to you, and via the magic of the internet, fingers crossed, we can see your screen passing. presenter privileges over. Hopefully, you should, if you hit the quick start button and hit share. Oh, look at that.
Yeah.
An absolute pro.
It seems to work. There we go.
I can see the screen. Perfect.
Okay. So we're going to talk about known IOCs, unknown IOCs, and also how to do actual prevention here. But before I start with that, I just wanted to show you the first page of this app that we have called Security Essentials for Ransomware. So some of you guys on the call might be familiar with Splunk. Some of you guys might not have seen Splunk at all. But essentially, we bring the data in, we apply these lenses on top, and here is a lens or an app that we call Splunk Security for Ransomware. And it ties into a lot of the stuff that Adam spoke about before. Detection in various different ways, detecting known bad things, but also some unknown, basically behavioral-based detection. And it also comes with some ways of applying prevention. So the prevention techniques are actually part of the Splunk core platform. So just the normal functionality of Splunk, but we'll apply them in this ransomware way. There is also some ready-made dashboards that highlight your current posture when it comes to ransomware, which I might show you. So there's a dashboard that looks like this, ransomware posture overview, that looks for typical indicators that you might be basically attacked by ransomware. And like Adam mentioned before, having patching is really important. So we have an indicator here that looks for specific CVEs that are linked to ransomware. We also look for an increase in SMB traffic, which might be an indicator of that. We also look for Tor traffic and things like that. So overall, giving you a security posture to see if you might be impacted or not. So if you have a massive ransomware outbreak, you will see massive changes in these indicators here. Okay, but back to the scenario where I'm going to look at a known IOC. So here we have, so basically what I'm doing here, so all of these searches here, so each one of these is a search that caters to a specific thing. So I'm going to look for known, see if I can find which one it is, ransomware extensions here. So this is if you know if you're being attacked by a known ransomware family, because there's only a couple of families out there, they will create files that have a specific extension. So WannaCry had wcrypt or something like that, and there's 20, 30 of these other extensions. So if you just have a search that continues to look for these files, you can very, very quickly find out if you're being impacted or not. So here we have an example of that search. It looks like this. This is Splunk search language. You might not necessarily understand what it's doing here, but it searches for file changes on any of your hosts. It maps that against the known, basically a list of known ransomware extensions here. That's what it's doing. And when I run that search, I essentially get this back, right? So I have the host name, I have the image, basically the file that's being run, and we have the files that was created from that. So you can see this system is littered with ransomware. That's right. So you can tell Splunk to continuously look for these things and flag that up to you to a central location. So that's one way of detecting. Another way of doing it.
I guess. Sorry, Johan.
Yeah, go ahead.
I guess that image is the file that's changing those files. So that's the sort of process that's written those files out here, where it says the image column.
Yes, that's what that is. So
I imagine that's really useful for customers if they get that information, they go and find out that okay, well here's some extensions this file's been writing. They can probably use that piece of information to then go and see if that exists elsewhere. Is that how you can start to leverage that?
Oh, absolutely. If you have this file name, and even better, if you have the file hash, and there's many ways of getting the file hash out, even on normal Windows systems, you can extract the file hash. And that actually takes me nicely to the next scenario. So if you have one of those files, you can detect, if you manage to detect the file hash, so here we have a file called osk.exe that we have detected it's writing a lot of files. And we also managed to extract the file hash from that. And in this particular scenario, we're using something called Sysmon, which is a free-to-use Windows product. It's from Microsoft. You can install it on your endpoints, and it will extract the process that's running and the file hashes of the process running. Actually. So we have this file hash, and you can then map this directly to VirusTotal. Right? So there is a VirusTotal app that is free to use with Splunk. So I'm going to pivot over to that. If I paste that hash in here, you can then see what is the current hit ratio of this one. So this is the WannaCry file hash. So you can see that every single scanner on Earth detects this one now. Well, actually, this one wants to miss it out. And as Adam mentioned, this there will always be, well, hopefully be one scanner that at least detects this as being malicious, and you can get a very, very early detection by doing so. So you can have Splunk scan for files that are doing strange things, extract the file hashes and map them to virus totals, and that might be a better way of detecting things than using your normal antivirus, because your normal antivirus might not be updated on time, but virus totals should be really, really good at doing that. So,
Johan, I like to think of this as a free way of getting 61 antivirus engines for the price of one.
Absolutely, that's absolutely true. And this can be then automated. So you have like every 5 minutes you look for some file hashes, you run the checking as virus total, and then you can immediately send you an email, or you can take some kind of action on the back of that. It's an excellent way for known IOC detection there.
So Johan, we've obviously talked a little bit about known IOC, and that's great where you understand your IOC, or but what about if you don't understand that, you don't have that file hash information? How can we leverage Splunk to start to look at some maybe behavioral stuff and maybe changes in traffic? Can you talk us through a bit about that?
Yeah, absolutely, and you're right. There will probably be a ransomware in the future where it is essentially a 0 day. Something is dropped out. No one has ever seen it before. It starts wreaking havoc all over the internet and all kinds of companies. And these behavioral-based detection, known detection mechanisms I show you now might not necessarily work, because we don't know what the file extension will be. We don't have the file hashes. It's impossible to know. So the only way to detect those things is by using behavioral methods. And as a part of the use cases that I showed you on the very first slide, there's a lot of searches that just does behavioral detection. And I'm going to take you through 2 of these now. The thing with these behavioral detection mechanisms is that they're a little bit more complicated to understand. We're not just looking at a single hash and you're comparing it against a known database. Here we're looking at specific things, and we need to do some statistical calculations. So the first one I'm going to show you is finding start anomalies from sysmon events. So basically, what I mean by that is I'm going to look for a process that is being started with an extremely long command line sequence. Because what we find when we analyze ransomware and viruses in general is that they will run a command line on the endpoint or on the server that it has an extremely long length. So it will be a very, very long command, much longer than you would normally have as part of the operations of your normal business. You will write typically shorter commands. So here I have a guide, essentially this is part of the pack as well, that takes you through step by step, find basically processes being started, and plot out the length of the command lines. And it's a 10-step process here. But in the end, we also apply some statistical analysis. So we're baselining each host. Each of the hosts we're baselining to figure out what is the average length of the commands they're running when they start a process. And then we compare any new command line that is being run against that baseline for that individual host. And whenever we have a 4x standard deviation threshold, that's a number we picked there. So 4x the standard deviation. We then basically create the alert. And the search then looks like this. So in this particular scenario, it's a demo scenario here, right? We find one host where this is the command that's being run, right? It is 4,400 characters long. Average is 100. So this host usually run commands with 100 character length, and the standard deviation is 256. So it's vastly over the threshold that we put here, right? So this is the command actually that WannaCry was using, and it's kind of embedding the actual script for the actual source code for the encryption is embedded into this command, and that's why it's very, very long. So this is one way of doing it. The command's a little bit more complicated, but that's one way of very early detection and detecting things that you have no idea what they look like before you search for them. So this is part of the infection phase. So this is when the ransomware is installed in the first place. You would see these type of things, right? Now I'm going to take it to the next scenario. So when the ransomware starts to encrypt your hard drive and your network shares, you will find the best way of detecting that is just by counting up the number of network writes or the number of file writes you have for a given host in a given time window. And when they start encrypting things, you will see a spike in write activity. So regardless of what the ransom family is, or for any ransom family in the future, you will see a spike in write activity. So that's a very behavioral technique that is extremely powerful. And here we have a Splunk search that is essentially looking for the search where there are more than 10 file writes in the 1 minute window. And we're also baselining that per host to figure out that is this normal or not, right? So it's searching that. But you don't really want to be at this stage. So this detection mechanism is quite late. If you detect the ransomware at this stage, you're essentially already infected and it's already starting to write things on your hosts. So how do we prevent this in the first place? How do we actually do something, take this to the next level, right? Instead of just preventing this host from being written, you perhaps want to do it even before you get to this stage. And that takes me to the last part here, the prevention phase. How can you use Splunk to actually prevent this from happening in the first place? So the graphic I'm showing you here is the timeline for most of the ransomware we've seen today, where the first little box here is the first search that I showed you. So the search where we had a very, very long command line execution. That is when, and you can see here that it actually came from a .m file that was probably on a USB thumb drive. So the classic USB thumb drive that someone opened, and it opened in WinWord. So Word opened that file, and Word then ran a command that was extremely long. That is what that detection mechanism is doing. And then we have a bunch of different commands here, which is the actual encryption activity, which started here. So this is the search I showed you previously, where you have this particular file, osk.exe, is making a lot of file writes. So more file writes than what you normally see. So that starts here. And then in the end here on the timeline, you see task kill osk.exe. So basically the file writes are all finished. The encryption is unfortunately completed at this stage. And then you can see that is around 25 minutes after. It took 25 minutes to completely destroy this host. But you see here that there's a time difference between the very first dropper here, when the command is executed, and the encryption activity actually happens. And it's around 4:49 and 4:43. And that is actually a deliberate delay that a lot of these ransomware families have. So the server ransomware had 5.5 minute delay. WannaCry had something else. And the reason to have those delays is to circumvent typical antivirus tools. So if you have a new file being created on the system and it immediately starts writing files, many anti-malware tools or virus tools will actually detect that. So they add in this delay here to kind of make it look benign, even though it's not benign. So what we want to do is here, when we have this search, we want to prevent it directly at this stage to never get to the second and third stages here, right? So how do we do that? If I go back to the very first search, I'm going to go back to this search here, which I have in this window. That's the search. It results in I find this host that run this super long command. And in Splunk, you can then configure it to alert. So this is the action that comes by using Splunk as a platform here. Click on alert here. We call it ransomware outbreak or something like that. And I want to run that, say, every minute. Let's just replace it with run it every minute. And what do I want to do when this happens? I can, of course, send myself an email when it happens if I want to. But what
I like the Domino's order pizza. The Domino's order pizza seems like a good option. You know, if we have a ransomware outbreak, that's the first thing I'm doing.
It's going to be a long night. So you can do that. So this is a ready-made API communication that is written by either by Splunk or by the community itself, or you can write your own integrations here as well, because it's a framework. But the first thing we're going to do is probably quarantine this host, because if you see this, you know that he's going to try and spread over the network, perhaps using the Eternal Blue exploit, right? So quarantine the host on the network. You might want to open a ticket in your ticketing system as well, saying, okay, this, and we can also pre-populate using tokens here, right? So we can have perhaps the command line goes in the description there or something like that. So you can dynamically attach that to the ServiceNow ticket. And you might want to say log out the user or something like that. Or maybe, for instance, this one, delete the file. You could actually, if you have a powerful endpoint agent, you can actually take action directly on the endpoint by maybe deleting that file or something like that, right? Perhaps logging out the user. So send myself an email, that's all I want to do as well. So you can configure that. So here we have early detection by using behavioral mechanisms, regardless of what the ransomware is. And we can prevent that from spreading in the first place by having direct communication to the firewall and to the endpoint and to any other system really that you need to have communication with to enforce that prevention. Right? So Splunk enables you to detect, and it also enables you to prevent early outbreaks. Adam?
Johan, am I right in saying, the guys, if they move ahead with this, they don't need to set that up for every computer? You're really setting up that alert for that search term, which is looking for those long file streams across any device. This is a kind of set it up once, and then your alert's going to work across everything. Is that fair?
Absolutely, yes. Since we're bringing in data from all your hosts, this is not tied to a particular host or a particular system. It just searches across the board, and if you run that search every minute, it will, take action immediately on any host that comes up in the search in a nanosecond, or microsecond.
Perfect. That's amazing. I guess that's so much easier. You haven't got to go out and manually do that inspection across all your different hosts in your environment. So much quicker to do that once, have that set up, understand what it's going to do, and have an automatic response.
Yes.
Perfect. So.
Go ahead, Dan. Go ahead.
That's okay, Johan. You're gonna. I guess I'm just looking at the time. I know we've got this booked in till 1:45, so I didn't want to overrun too much if we can avoid it. I think we're kind of showing people, how they can use the Splunk platform to look at known scenarios, how they can look at unknown, and how they can sort of tie that together with some of the automated alerting. I just wanted to quickly jump back and just as the last thing to talk to you guys about is this, that you can go and try this yourself. We're not asking you to take it at our face value. There is this. The online demo is all available. You will be sent the slides after this demonstration, so you can have all the information and the links in there. You can go on and you can literally use the tool that Johan's using right now on his screen. You can access this. You can kind of see it and use it, in that demo environment, and just see just how easy it is for yourself to set this up. So. I'm just going to round the WebEx off now here and say, thank you very much, everyone, for joining. I appreciate it. We're going to open for a bit of a Q&A. There is a Q&A button you should be able to press to submit questions via text if anyone would like to. Me and Johan will stick around for 5–10 minutes and answer those. But for anyone else who's got to jump off, I really appreciate your time, and I hope it's been useful. Thank you very much. Thank you, Johan. I appreciate your time.
Thank you.
Perfect. So if anyone has got any questions, you should have a text box. You push up to the top, or in the top right-hand corner is a Q&A button. You can submit them via text, and we'll answer them. Johan, I'm never sure if they don't ask any questions, whether we did a good job or a bad job.
I think people are just a bit shy.
It's always the way.
Yeah.
So we've got a question from Mike. So Mike's asked, does anyone offer a cloud-based service so we can outsource the effort? You can take Splunk as a cloud-based service. Johan, do you want to talk a little bit about that?
Yeah, sure. We have many, managed service providers that run Splunk as a security product for our customers. So absolutely, Splunk works in a cloud-based environment. We can capture the data from your on-prem systems, send it up to the cloud using, encrypted ways, so it's completely secure. And the detection and even the response can be run from cloud servers. So yes.
I think Ryan asked, is it recorded? I am not sure. I need to check with our marketing team whether or not somebody hit the button. As usual, it's somebody has to hit the button at the beginning, and I definitely didn't because I forgot. So potentially I'll let you know. If you have a look, we'll put it up on our LinkedIn or Twitter if we've uploaded it somewhere. It's worth mentioning about that cloud-hosted option as well. We have the option at Softcat. It's a service that we will be going live with in probably the next 6 months or so. So it is something we're looking to build up and bring online. So I'm more than happy to talk to you guys in more detail about that once that is officially live as a service.
Adam, it's Michael here. I can confirm we've recorded it.
Good work, Michael. Thank you very much. I'm glad you pressed the button because I forgot to. Okay, so Paul O'Leary's got a question. Do you have to install something on every endpoint? So, Johan, do you want to take that one? It does all totally depend on the data you're pulling back, but yeah, in general, go on.
Yeah, so it depends. What I showed you in these scenarios were quite endpoint focused, using Sysmon and looking in the Windows security event log. You can extract these things from a central location too. So Windows has some capabilities to export Windows security events to a central server, and we will then capture the data from there. A lot of these endpoint agents as well, Carbon Black and Semantic ATP and these, you can get the data from the central semantic server, even though the data is coming from the endpoints from their agents, but Splunk will get the data from the central server. So it depends on the use case and what data source. But both scenarios are valid, essentially.
Yeah, Paul, I think, like when I was thinking about this, like when we wanted to tailor it, like we were trying to find things that you can get fairly natively out of the Windows event log as well. So a lot of this doesn't require, that additional tooling to pull that information out. Like there are system events that are created when you instantiate processes or to perform file writes. Obviously, it does require a bit of pre-set up in your environment, maybe configuring some GPOs and various things to set the correct level of logging, but it is a Windows native log rather than requiring some sort of additional endpoint agent. So, yeah, I think Johan's totally correct. It depends on the environment, but I think a lot of this is very achievable with stuff out of the box as well. Doesn't look like, oh, okay, we've got a question from Christo. Apart from cloud hosted, does Softcat plan to provide this as a managed service as well? There is plans to provide this as a managed service. I probably have already said too much anyway, but yeah, definitely it's roadmapped that we will be providing services like this in the near future. Once we have more information, we'll come back to you, Krista. Okay, is there any more questions? Let's have a look. I don't think we've had any more come through. Well, if nobody's got any more questions, we'll hold on for a minute or so more to allow any last-minute typers you want to ask anything else. But, yeah, I just want to thank everyone again for their time. I appreciate you guys coming on and having a listen to what we have to say. Johan, thank you so much for your time and, coming and joining me. I really appreciate it. So thank you very much, guys.